Hello and welcome for the Stats Equation 2 program for your TI84 calculator. Basically, if you're in any kind of intro stats class, whether it's AP stats in high school, regular stats in high school, or university level stats first semester class, this is the program for you because it has all the formulas you probably need. And then also worked out with a lot of different examples, solving for the most case in for different types of variables. So you'll see, and without further ado, here we go. And I'll just dive right into it right now. Okay, so let's look at descriptive stats. So it can basically give you the calculations for all these values, the mean, median, mode, variance, standard deviation, and range. And it's basically giving you the formulas. And then for mean, oh my gosh, it gives you actually, I didn't even point this out. It solves for any of the missing variables. Like let's say solves for mean. Mean is the sum of values divided by count or the number of values. So let's say the sum in the number of values is 100 and you have 10 items there. The mean is going to be calculated by 100 divided by 10 and 10. So this is a hallmark feature of almost all of the formulas in this program. It gives you an example and it shows you how to calculate it. So let's just walk back to getting the mean again. And let's say if we solve for total values there. So the sum of the values is the mean times the count. So let's say the mean is 10, the count is 10. The sum would be 10 times 10, which is 100. Let's go through it. Descriptive stats. Let's just do median. It's kind of easy here. If there's an odd number of numbers, it's going to be the middle value. If it's an even number of numbers of n, it's the average of the two middle values. So the example for the odd is like, let's say we've got 3, 5, and 7 as our three data points. The median's 5, right? Because that's an odd number of values. But if we had an even number of values, like say 3, 5, 7, and 9, it would be the average or the sum divided by 2 of the middle two numbers here. So let's go descriptive stats again. Let's go to mode. Just gives you a simple description. It's most frequently occurring value. So if it's, say we got the values 2, 4, 4, 5, and 6, the mode is 4. There are some examples where there's no mode, there's no data value or no number that's repeated, so there'd be no mode there. So I'd like to go to descriptive stats again, and then variance, and then this is what's cool. We get the formula right here, and let's say we wanted to solve for variance. It shows you, okay, cool. Little sigma squared equals 1 over n times the sum of x sub I minus x bar quantity squared. Sum of squares there. So let's say n equals 5, and then the sum of x sub I minus x bar squared is 20. And then this is how you actually calculate the variance. So it's wonderful that way, especially if you're just getting into stats. You want to know, like, hey man, I want to do standard deviation. Oh, and I want to solve either for sigma or for variance. Let's say we want to solve for just standard deviation. It's a square root of variance, so the variance is 4, sigma is square root of 4 and 2. So again, for this one, if you wanted to check out the variance, to calculate the variance for something, go ahead and go check out the variance version of this. Let's see if there's any more here. Range just gives you simple range is max minus min, and you can solve for range, max, or min. Because look, any kind of math prof, worth their weight is going to be giving you like, oh, I want you to solve for max, I want you to solve for min, all these variations. So like, oh, the min is the max minus the range. Oh gosh, I would have loved this in a stats class. Oh my goodness. Okay, let's go to probability and events. Huge submenu here. Got basic probability, complement rule, union for mutually exclusive events, union of non-mutually exclusive events, intersection, and conditional. Let's do basic probability here. So probability of event E is favorable outcomes divided by total number of outcomes. So let's solve for probability of E. And it's, probability of A or B is probability of A plus the probability of B. There's a more extended example when you talk about this is a mutually exclusive event. That's just assumed there. But let's do probability of events. And non-mutually exclusive, number 4. So probability of A or B is probability of A plus probability of B minus probability of A and B occurring at the same time. So let's do number one. It's just like, oh, okay, here's the example again. I don't need to walk you through it. I kind of think you can kind of just see with your eyes what's going on there. And then let's do that again, probability of events. And then if we want to do probability of B, because, they asked that, probability of B would be probability of A or B minus probability of A plus the probability of A and B. And again, numbers so you can kind of walk yourself through an example. Now, let's see, probability. Let's do permutations and combinations. Let's talk about permutations. So it's permutation of n comma k is n factorial divided by the quantity n minus k factorial. So it gives you great examples to kind of walk through to get you used to this stuff. Let's do factorial. Just so if you don't know what that exclamation point means in math, it means factorial. So if you had like, say, 5 factorial, it'd be 5 times 4 times 3 times 2 times 1. So 5 factorial is 120. It's also, actually, you can find this in the catalog under math in your calculator. I don't want to go there right now, but I'm sure there's many videos that you can see that'll bring you to that. Okay, so I think all the probability. Let's talk about distributions. Let's talk about a probability distribution. So the mean, mu, this looks like a cross between an M and a U. It's actually a Greek letter mu, mu. So it's the sigma, which means the sum. That's what this Greek letter means, capital sigma. X times probability of X. So standard deviation, the mu, and this is little sigma, by the way, so that's capital sigma, little sigma there, is the square root of the sum of x squared times probability of x minus mu squared. So an example, we give some x values, some probability values for those x values, and then calculate the mu, so that's 2.1, and then sigma would be the square root of, all this gobbledygook, which is 0.83. So that's awesome. If you have this on your stats test or quiz, you're like, oh my gosh, what do I do to solve for this? Wow, just kind of follow along the example. That'll save your bacon. Okay. Okay, so I think we're at distributions again. Let's talk about binomial distribution. So I don't even want to read this out loud. It's kind of complicated. But again, here we are with an example. So here it is written out for you. I just want to show you the menus pretty much if you're on the fence about buying it or would like to see how to use it in its entirety. Okay, let's just go back here. And then confidence interval is a big thing in stats. So, we have one population or two populations. They usually, in an intro stats class, won't go beyond that. I know they go 3 or more populations in more like 200 level stats class, like a second year stats class. But let's talk about one population. So proportion, that's not fat, that's p hat. I know it looks like fat. It's p hat minus e is less than p hat plus e. E is typically the margin of error. It's the z-score of alpha over 2, I'm going to 2-tailed test, I believe, times square root of p hat times q hat over n. The mean x bar, and it's usually x with a bar over it, but I can't do that symbol on the TI84, so I'll call it x bar, minus e, minus mu, minus x bar plus e. Error is, now this is the t test statistic, alpha over 2 times s, divided by square root of n, where sigma is unknown. So there's just 2 examples here. Sigma is unknown and sigma is known. Variance gives you the equation for that. Example, x bar is 50, s equals 5, n equals 25. It gives you the calculation for the e. The rest of the stuff is going to be given to you like the p hat, typically, and then the x bar. Let's go on. And we did, I think, confidence intervals. Let's do 2 populations. So there you go. It's a little more complicated than the one population with all the p hat and the margin of error there. So let's go on to sample size, something I wish I had known a lot better when I was taking stats. So we've got a proportion with an unknown p hat or a known p hat. Let's do unknown p hat. So we've got n equals z-score alpha over 2 squared times 0.25 divided by e squared. Gives an example of some numbers and walks you through it. So you need a sample size of 385 there. Okay, sample size, let's say known p hat, and it's a slightly different equation. And then look, if you get a sample size, and this is what I don't like about stats. I mean, one of the few things I don't like. Sometimes you round up, sometimes you round down. So in this case, you get 368.38, and the number in your sample size, this is going to be rounded up. Key detail there. Again, I don't like missing the answers by 1. That kills me. Okay, so that was sample size. Let's look at test statistics. So we've got proportion, mean, standard deviation / variance, because variance is standard deviation squared. Just likewise, standard deviation is a square root of variance. We've got various tests to run. This option 4 is probably what you want, so we'll get to that in just a minute. Let's talk about proportion. So again, gives an example. P, and then so this is also another thing. So they talk about P, probability of something happening, or P hat. Q is 1 minus P. Sometimes they call that negative P, and or P to the negative 1. There's different ways of calling it in different textbooks, different teachers, different classes. So just Q is 1 minus P throughout this program. Just a heads up there. So let's go on, and then test statistics again, and then mean gives you the sigma of x divided by n. So sigma x is 250, n is 25. That's how you find the x bar. Pretty cool thing there. Let's do standard deviation variance. And then that looks like a chi-squared to me. But that's okay. That's okay. Test statistics. I do want to go through the various tests. This is key here. This is probably where most people are going to watch this video. So do we want z-test, t-test, chi-square? So z-test gives you the z-test there. And then test statistics, various tests. So the t-test, this is what you're looking at for the basic formula for a t-test. I think they call it the student test in some books. Okay, and then test statistics, various test, chi-squared. So chi-squared looks like this cursive x. It's usually a little bigger. It's the sum of observed minus expected squared over expected, I believe. So there you go. The basic example of how to do chi-squared test. Now, here's the big thing. Actually, is 8 is going to be test selection, but let's go through hypothesis testing. Just want to talk about null versus alternative hypothesis, critical regions, and the p-value method. So, oh man, this would have helped me so much, so much. Oh man, mcstutoring.com, baby. Go to it to get your stats programmed, like if this thing's helping you. Yes, so let's talk about null and alternative hypothesis. So this is H sub 0. I can't do a subscript too easily. And the variation is the alternative hypothesis, which H sub A. So H sub O, null hypothesis, assumes there's no effect, like basically no change in something. H sub A is alternative hypothesis, which opposes H sub O. So let's say the example of null hypothesis is the mu is 50. So the alternative would be mu is not 50 in a two-tailed test. So if it's equal to 50, it'd be like greater than 50 for the on a right-tailed test, meaning you're finding out stuff to the right of 50, or less than 50 if it's a left-tailed test, value less than 50. So H sub O is almost always equality, by the way. So it's an equals. Okay. And then hypothesis testing. So critical regions. So you compare test stat to critical value based on alpha. So sometimes, alpha is 0.1, 0.05, or 0.01, just depending. So 0.05, let's say for two-tailed tests. So critical Z values would be plus or minus 1.96. It's usually found in a table or chart in your stats book. So if Z is 2.3, you reject the null hypothesis. And if Z is 1.8, you fail to reject the hypothesis because it's inside the value there, I believe. So you fail to reject the hypothesis, but it's greater than the absolute value of this, you reject it. Okay. And then we go on. I think was that it? Okay, and then p-value method, probability of observing result as extreme as the test statistic. So let's say z is 2.3, alpha is 0.05, and the p-value is 0.021. Since p is less than alpha, you reject the null hypothesis. If p is greater than or equal to the alpha, you fail to reject null hypothesis. Those are the two conclusions you can reach. Basically, you reject null hypothesis or fail to reject null hypothesis. Pretty key there. And then let's do test selections. Now, this is the big thing. I was trying to get a flow chart on this. I wasn't able to. But first, you have to answer this question. How many samples are we talking about? Let's say we're talking about one sample. And then if it's n is less than 30, you use the t-test. Greater than or equal to 30, use the z-test. So let's go, boom. So one sample t-test example is the mean GPA, meaning average GPA 3.0. Samples 25 students. Use when n, the number of items in your sample is less than 30. Let's do that again, test selection. I really like this because this just helps explain things. And then let's do 2, which is greater than or equal to 30. So is the mean height of, say, a sample 65. Say you have a sample of 50 people. Okay, use it when n is greater than or equal to 30. Z-test. Okay, we keep going. So test selection. Let's say we've got 2 samples. And is it independent or paired sample? Let's say it's independent. So 2 sample t-tests, compare scores class A versus class B. They're different students. Let's talk about test selection. 2 samples, and let's say they're paired. Paired t-test. An example is before after for like a weight loss program. See, this is so helpful. Look, it's not going to get you like an A+ on your stats, test or final. I mean, it may be if you're already getting like an A-, but it just helps like, oh yeah, this is like a before after. This is what you'd use a paired t-test for a weight loss program. Like, my goodness, typical example. Okay, test selection. Let's say greater than 2 samples. So it's one way. ANOVA, which means analysis of variance. So you compare 3+ methods, different teaching styles, multiple independent groups. So there you have it. You've got the main menu for statistics equations 2 right here. It's available at mcstutoring.com. M as in Mary, C as in Charlie, S as in Sam. Like the video if it helped. Subscribe. We're constantly making new programs. I am making a stats equations, actually a stats solver, but that may take till next semester, so don't get your hopes up. It may take like January 2025. But if you rant and rave in the comments, I may expedite that. Because I know on the East Coast and the South in America, because I'm familiar with those systems, you guys have finals before Christmas. For some reason, California public schools, where I am now, man, the finals are like after Christmas. It makes no sense to me, but hey, that's just how it rolls. So look, good luck on your stats. I'll catch you next time.